Hello, grade 11, how are you? I'm sorry for the sound issue, and I'm recording this video to help you to understand our lesson today. Our lesson today is talking about rational functions. Before we talk how can we translate the quadratic functions, okay? Today we are going to study how can we translate and deal with the rational functions. First, let's know what is the rational function. The rational function. The rational function is a function whose rule can be written as a ratio of two polynomials. Ratio, it can be written as a ratio of two terms or two polynomials. Okay, طيب. What is the parent function? What is the parent rational function? The parent rational function is f of x equals 1 over x. This is the form of the parent. This is the form of the parent rational function. Okay. What is the standard form of the rational function? The standard form of the rational function is f of x equals, make fraction part to make it rational, a over x minus h plus k. Okay, this is the standard form of the rational function. Okay, طيب, let's know what is a, h, and k. A, h, and k represent what? Let's talk about a. The absolute value of a represent the vertical stretch or compress factor. Vertical factor. So the absolute value of a represents vertical stretch or compress factor. Okay. طيب, what about h? Do you remember? As we took in the quadratic function, h represents horizontal translation. So this means if h is smaller than 0, so the graph will translate horizontal. So horizontal means moves left or right. Left or right. Okay, so if h is smaller than 0, so the graph will translate left. Yes. Okay. طيب, if h is greater than 0, so the graph will translate right. Okay. طيب, let's talk about h. H represent what here? Yes, H represent a vertical translation. A vertical translation, where vertical translation means what? It's going to move up or down, up or down. So this is K, not H. K, sorry. Okay, so if K is smaller than 0, the graph will translate down. And if K is greater than 0, so the graph will translate, yes, up. Okay? Okay, so let's apply this concept by using an example. Example number 1, here I want to use the graph of f of x equal 1 over x as a guide. This is a parent function to describe the transformation of g of x equals 1 over x minus 3. Okay, this is our function. I want to describe the transformation of this function by using the guide function or the parent function 1 over x. Okay, let's see here. Here, do you have any h's? Do you have any h's? Yes, this is the value of h. Okay, do you have any k's? No, there is no values here, so k here is equal to 0. So write the values. H here equals, is it 3 or negative 3? Do you remember? Yes, it's positive 3, because this negative is for the sign. We said that before. The standard form is a over x minus h. So this negative is for the sign, the rule. This negative is for the rule. It's fixed on the rule. Okay? So the value of h here is equal positive 3. Okay, what about k? K equals 0. There is no k's here. Okay, now we can describe the function. We're going to say because h equals 3, so the function translated 3 units. Left or right? Yes, right. All because h equals 3, so the graph translated 3 units right. Okay, this is for number 1. Let's take another example. Number 2, g of x equals 1 over x minus 2. 1 over x minus 2. First, let's identify x's and k's. H's and k's. Do you have any h's here? No, so h here equal 0. Do you have any k's here? Yes, k here, this is the value of k. K here equals negative 2. So let's describe the function of the transformation. We're going to say because k equals negative 2, so the graph translated 2 units. 2 units what? K represent what? A vertical translation, and it's negative, so it's 2 units down. Okay guys, I'm going to give you 2 examples to do it as homework, okay? The homework here. Number 1, g of x equals 1 over x plus 4 Number 2, g of x equals 1 over x plus 1. Okay, please do these 2 examples as homework. This is the first part of our video. I'm going to record another part to complete our lesson. Okay.